this new arrow technology. This is going to be something I think once it gets traction and the word gets out. The guys that we had field testing that put these on their arrows, and I'm going to tell you truthfully, this was designed for, these got to be glued in. This was more designed for blood trait capabilities on a bad hit. If you got an arrow stuck in there, no exit hole, and nothing coming out, you'll get some blood flow coming out of the back and you'll have something to track. So when we designed this, it was for that, and we started shooting it, and it was like, we thought, man, this is gaudy. It's heavy. It's had 57 grains. So at 40 yards, you traditionally would shoot 4 to 6 inches lower. At 40 yards, we're shooting 3 inches higher. So on long range, now out of the gate, it's not doing anything different than another arrow, but this arrow defies the wind velocity and drag on an arrow with this. It's called a vortex generation on the front. It's basically, in layman's terms, it's punching a hole through the atmosphere and letting the arrow slide in behind it without drag. Just like on a target or how you get the drag stops an arrow. So this thing on your target, it penetrates deeper, it travels further, and it's steadier. It gets on line wherever it goes, and it don't want to change direction because of wind. And there's some other technology that's on there that...
So is it that the wind is allowed to pass into the shaft and then back out?
You know, like a gyros, I think they call it a gyroscope is, something that's moving, and they call it the gimbal, the axle that it's on, it stabilizes it. Like a grinder, you got that thing wound open, you can't change the direction of it. This has flutes that sucks the air in. It's running, the air inside's not spinning, the arrow shaft's spinning.
Yep.
So now that, at traveling 300 feet per second, that arrow's like an axle in there. And this thing's spinning, it does not want to change direction. And I'm a lousy shot, I'm going to tell you right now. My distance is usually 20 yards. I can reach out further, but I know consistently, shooting out of my head with this. All these other guys, they're just pounding targets at 40. And again, we got engineers testing this now to find out what's going on really with it. We're working with Victory Arrow Archery now. They're an arrow manufacturer, going to manufacture our arrows. But here's kind of what it's kind of fuzzing up. You can see how much bending is in there for blood flow.
So then is this something that would come as a finished arrow, or is this something that guys could buy that
you could buy
insert
the
type system and put on their standard diameter?
So all the guys started with an insert. All the guys would get an insert. They just take the insert's glued in there already. They'd cut that right off, leave that insert in, plug this in, and you end up with about the same arrow length. You glue that in, and then you take off your back. That's why we're going to do an arrow, because it's a little more difficult. I use the 4.5 inch feathers. You want to cut the back off, and the extra 3/4 of an inch you put an insert here would go in and replace it, and you stay the same length. So with these, you got enough room on there. You can literally just plug your insert in, and then just knock a little off to get your height. So we thought, it's kind of, for most guys, they got to go to an archery shop to do it. So we thought we'd offer an arrow completely ready to go, so they can just buy the system.
What's the diameter, do you know, of that?
This is
component?
a 0.244, I believe, is the. And right now the insert's only designed for that diameter arrow.
Yep.
But we're working with someone to do an outsert for the small diameter arrows.
Yep.
And problem is, when you get down to smaller diameter, there's no tunneling for the blood to flow through. So now we have to get on the outside instead of the inside. These are just basically glued in. And they're pretty tough. We've been shooting them and shooting them in the ground, re-spinning them and using them again. So
I noticed that the little ribs on the exterior are bigger than the diameter of the broadhead. Are they thin enough so that they kind of act almost like smaller type blades?
Actually, I'll let the cat out of the bag right now. We're taking this technology and we're going to make a broadhead with it.
Okay.
So down the road, you'll probably be able to plug blades into this actual insert.
Gotcha.
So the idea behind this was, when it gets into meat and blood and coagulation, it wants to plug up holes. So these are trapezoidal shaped. They keep the meat out, and it still lets little veins for the blood to drop down in and get an arrow. We were looking at treating the inside there so that blood would go through easier, and we already discovered that these carbon arrows, you drop a drop of water in there, it beads out. There's no cohesion. It goes right through and out the backside, so they're already set for blood to flow through. The one deer that I shot this here. I'll tell you a small story. It was a 10 point, and I took it down through the front of the shoulder, down through the neck area, went into the boiler house, and there was this much arrow sticking out of it. At the point of impact, there was a 10-foot radius of little droplets, and this is the first kill with this system. All around, I thought, oh my God. And I got it on video. I said, I got it. This is the holy grail of video. So any other shot, there would not be a drop of blood coming out.
Right
out high in the neck, and the arrows, stuck. So I had good blood for 70 yards. And it's weird. The blood is not like a tracking coming out of the animal, so it throws you a little bit. It's out from the animal a little bit, so you have to kind of take that into account. But then all of a sudden at 70 yards, no blood. So I'm there for an hour and a half trying to find this deer. It's thick. Blowdowns on a mountainside. Finally got downwind, got a wind of its tarsals, and frickin' went over to it. And lo and behold, the arrow was gone. And I'm like, what the frick's going on, Then I started thinking about it. I went right back to the spot. It was a bunch of deadfalls that just crashed through. Right where that blood stopped, that arrow snapped off. That hole closed up tighter than a drum. Even when it was laying right there was no blood laying on the ground. And this shaft was sitting there like this, with lung blood just still spilling out of the vent. So again, this ain't going to be 100% on every non-pass through. But if you ever get in the boiler and hit the opposite shoulder and it's through muscle and tight and you don't have a lot of blood, wouldn't you want another couple extra drops to follow? And the original idea behind this was for me as a trophy hunter, the most big deer I've lost are from one lung hits. And what I wanted to start going is that if a deer's lung, the opposite one isn't damaged, they're going to make it. They're hurt. In some of the hits that I've made, I could not believe a deer could actually live another year. If there's no external air coming in the chest cavity to cave in the other lung, if that hole's tight, that deer's going to live. I thought with this venting, if that allowed external pressure to come in there, it would cave a lung in. So I started on that line of thinking, and I had 2 deer in my lifetime that I've shot through a shoulder that were killer hits with no blood to follow. And I found both the deer because I finally did get blood, and the arrows had snapped off. And just the broadhead loosening up on the threads in the chest cavity allowed enough blood to travel through that and out that arrow for me to pick up that blood and find that deer. It would have been dead, the neighbors would have found it, the coyotes would have got it, but it gave me extra tracking. So I thought, a lot of guys with these expandables now, very not good penetration, a lot of not pass-throughs. It's weird, a couple of buddies of mine are big trophy hunters, they say, man, we're having problems, we're not getting pass-throughs anymore. And I said, well, what are you shooting? He says, well, expandable. I says, well, that's why. So, I thought somebody told me about what I was doing. I said, come on, you pull my chain, right? You know that I got this new thing coming out. No, what are you talking about? So I got something for that, but their arrows are hanging out a little past, and this is going to do nothing for that. But like I said, I don't know about you guys, but when I hit a deer and that arrow won't go through it, I sit there and I pray to God that there's some blood. I'm going to get down and find some blood, and normally there's not. And it's, you start, so maybe our prayers are answered. Maybe there'll be more, and we'll be able to find more deer and have less go to waste. So, but again, secondary consequence ended up being bigger and more of I think a contribution to the industry, because people have been with bows, been trying to get this extra distance with cams and with kinetic energy and all this stuff, and we kind of got lucky and got it with an arrow now. So, your bow will deliver that package further and flatter.
And what was the weight on the front and the back components?
I don't have the separation. I think it was 72 extra grains, and then I think the front's 50 some around there. But it puts a little weight back on the end. But it also put some in the front. And they checked the FOC weight on it, and it's perfect where it's at. So we got lucky in that area too. We didn't have to move any weight around. So.
Well, I think probably a side consequence too, I'd imagine people might look at that weight and say, oh, that's a pretty heavy system, but like you're saying, that extra weight's going to help penetration
I
anyway.
asked the experts. I'm not an engineer. Yeah. My buddy's son is an aerospace engineer. I said, dude, this is defying lot. One thing we can't beat is gravity, but wind resistance, they're beating it with race cars, with all kinds of efficiency. And matter of fact, I'm going to the military with this patent, because this is traveling flatter, more efficient at longer ranges. I mean, I can imagine this thing getting a long-range missile and just making it more effective. And the big thing is, I used light broadheads before, and you shoot your bow and you got the feel of how that arrow, and the kind of feel I had is almost too light and kind of all over the place a little bit of floating, a little bit too light. When I screwed that on, it almost felt like a rock just traveling, like the thing was just there, boom, boom. So I shot, and I don't hit the same holes with an arrow, and I was doing that. I was like, okay, what's going on here, you know? So I think we got lucky with a lot of that, but I think now some of these engineers that have that background should be able to take what's going on here, and they got to be able to improve upon it. So I would look for some good things coming in the next years. One of these big companies pick it up and start, you know, taking some of these engineers and looking at this. So